All right, everybody, welcome back to the channel. Today, we're going to look at how to take care of volume of some of those 3D objects like we were talking about last time when we mentioned surface area. So volume is basically going to be the amount that object can hold, how much space it actually takes up in our physical world. Which is a little bit easier to think about than surface area. We don't have to account for all of the actual surfaces that are exposed to air. We really just care about the inside when we talk about volume, and that makes it a little bit easier to deal with. So if we look at this pyramid here, and we go to try to figure out the volume of it, essentially the volume of a right pyramid with a certain base and height is 3 times smaller than the volume of a rectangular prism with the same base and the same height. So if you had a prism with a base of 4 by 4 and the height, which we have to locate here for this pyramid, essentially 3 of these pyramids would fit into that prism. Which, if you remember the volume of a rectangular prism, it is length times width times height. The area of the base of that prism multiplied by how tall it is. Now for this pyramid, we're going to need to divide that by 3. So there's the formula for our volume, a little bit easier than surface area. I don't have to account for all of the lateral faces along with the base. Essentially just the base area times the height divided by 3. The problem here is I have to remember which height I'm actually talking about. So the height given to us in this problem is actually the slanted height, the height of the triangular face. We need to find the height of the actual pyramid, which brings us to our Pythagorean theorem one more time. Just remember that vertical height drops from the apex to the center of the base, which does create for us that right angle triangle, which you see kind of outlined there in red. So I know that the bottom part of it is going to be 2. Since the whole dimension going through it happens to be 4 inches, like it says in the image, so that's 2. The height we are going to locate, so let's call that h, and 6 is the measurement that we're given. That 6 is the hypotenuse. So just off to the side here, our hypotenuse of 6 squared needs to be equal to h squared plus 2 squared. So if I rearrange that formula a little bit to get the h term by itself, h squared has to be 36 minus 4. In other words, 8 squared is 32, so that height is the square root of 32. And that number I'm going to keep just as a radical because I know I'm going to use it again in this formula. So if we plug some things in that we know now, the length and width are basically talking about the length and width of the base. Since that's a square pyramid, 4 by 4, we'll go 4 by 4 multiplied by the height, which we just found together was the square root of 32. And then we will divide that total product by 3. So then our volume becomes, so let's grab my calculator here, and we'll shrink that a little bit, get it out of the way. There we go. So this calculator can sit right underneath. Perfect. So if we take our 4 by 4 is 16, multiply it by the square root of 32, hit enter, then we'll divide that by 3. And to the nearest cubic foot, 30 cubic feet is the volume of this pyramid. So it is feet cubed because we're taking 3 linear dimensions and multiplying them together. So feet times feet would be feet squared, that would be area. Multiply it by feet again, and that would give us that feet cubed like we learned from exponents. So there's the volume of this pyramid, provided we have the correct dimensions. So I'll leave B as one for people to attempt and try out. That way, when you compare it to the answer key, like always, you can see how you did. So if we look at example 2 here, and I might need to rearrange, there we go. Determine the volume of a right rectangular pyramid with base dimensions 5.4 centimeters, 3.2 centimeters, and the height being 8.1 centimeters. We are asked to leave that volume to the nearest tenth of a cubic centimeter. Now again, the volume is length, width, height divided by 3. So let's take a look back at the question and make sure we have all the dimensions we need. I've got the base dimensions of 5.4 and 3.2. That takes care of the length and width of the base. And the height presented is 8.1. I have everything I need. I know it's the right height because it doesn't say slant height. It just says height. So that height we are taking to be the height of the actual pyramid. So if I plug all those numbers in, 5.4, not 5.2, 3.2, and 8.1 and then we can divide that product by 3. Let's see what we actually have if we grab our calculator. So we are going to take 5.4. We are going to multiply it by 3.2, also by 8.1. Get that product first, then divide by 3. And to the nearest tenth, 46.7. So 46.7, that is centimeters cubed. So there is our volume to the correct number of digits, everything where it should be. So this is actually quite nice that they gave me all of the measurements. Very straightforward. So again, I'll leave B blank. That way people can attempt it and compare to see how they did. Cones then work very similar like pyramids do with their rectangular prism counterpart. If you had a cylinder that had the same base and same height of a cone, 3 cones would fit inside of that cylinder. So the formula for the volume is the same as it would be for the cylinder. So the area, the base of that cylinder, pi r squared, multiplied by how tall it is, but divided by 3. Very much the same as it was for a pyramid. So as long as we have the radius of said cone and the height of said cone, we can find the volume. So if we plug those things in, pi is the constant, it stays there. Radius, just remember that the diameter is 6. The diameter is 12. The radius should be half of that, so our radius is going to be 6. So 6 squared. Height is 18. Divide the whole thing by 3. Now I can grab my calculator, put all that stuff in there. So pi times 6 squared. Pi times 6 squared. Close that bracket, and then 18 is the other one. And that says 1, so 18. Hit enter first, then divide by 3. And 6 to the nearest unit, so 679. Volume is 679, and that is inches cubed. So there is your volume using the correct formula. Also, include the units. That makes it super helpful and clear that we know which one you are talking about. So there you go. There's volume. We can also work backwards to find some measurements. So as long as I know that I've got a height of 4 yards and the total volume is 205, there's enough information here to actually find out what the radius is. So just remember that we are talking about a cone. So the volume of that cone, pi r squared h divided by 3. And we can fill in some of the measurements that we have. So we know the height is 4. I know the volume is 205. So I'm going to translate that into using the information that we have. So 205 is the volume, equals pi r squared. I don't know the radius, so let's leave it as r. The height, however, is 4. And I'm going to divide by 3. So in order to get that r squared by itself, I'm going to multiply both sides of this equation by 3 first, times 3, and then times by 3. So what that's really going to do for us is cancel the 3's out on the right side. So 205 is going to get multiplied by 3 to give us 615. So 615 is going to be equal to 4 pi r squared. So I just rearrange some of those terms. Let's make sure my math is right. 205 times 3. Be a shame if it wasn't going forward. So 615 is good. We're going to divide both sides of this by 4 pi. Okay, so 615 will get divided by 4 pi to give us this number. So I'm not going to write that number down just yet, because I know there's a couple other things that we need to take care of. So if I just write this up above here, we're going to have 615 over 4 pi is equal to r squared. Now just remember, we don't want r squared. We actually want the square rooted version of it. All right, I just want the radius by itself. So I'm actually going to need to take the square root of 615 divided by 4 pi. Now on my calculator screen, that's exactly the number I have here. So I'm going to take the square root of that number. Okay, and enter it. There it is. There is our radius to the nearest yard, 22. Nearest whole number, 22 yards is equal to that radius. Okay, we weren't asked for a diameter or anything like that, so just make sure that we are answering the question and providing it to the correct number of digits. So said nearest yards, nearest whole number, 21.9 can get rounded up to 22. So there we take care of that. So it really is that manipulating of that equation, which is going to get some people. So just take it slow, piece by piece. Attempt letter B It is organized very much the same, different numbers, so you can attempt that one and see if you can follow those exact same steps as I have. And you can always check the answer in the description. Okay, let's talk about a sphere. So when we talk about volume of a sphere now, again, there's a whole long explanation due to calculus on why the volume is the way that it is. But the volume of a sphere, its formula is 4 over 3 pi r cubed. So again, the radius is the only measurement, the only linear measurement that affects the volume. The bigger the radius, the bigger the volume. So I really just need the radius to do this. Now, we're talking about the moon, and it approximates a sphere with a diameter of 2,160 miles. That's an extremely large number, but again, remember, it is the planetary object. Like, it's a satellite up there. It should be quite large, right? So that diameter is 2,160, which means the radius is half of that. Right? So 1080 miles. And I'm pretty sure I divided right, but, let's just double check. We have the means too, so why not? 1080, there we go. So there's our radius. We can find the volume. So we'll plug that radius into our formula. So 4 over 3 multiplied by pi multiplied by 1080. That variable is not squared, but cubed. So that volume equals. So let's do 4 over 3 multiply it by pi multiply by 1080 to the power of 3. It is cubed since it's a volume. Everything's plugged in there, and there is our very large number, which we'll actually take all of it. We're not told where to, put it into certain scientific notation, anything like that. So 527 666 9286, and that is miles cubed. So the volume of the moon, quite large. Very, very large number, which we could write in scientific notation as well, but then we lose out a lot of that number, and it is a more rounded answer. So let's leave it with the whole bunch of numbers there, and there you go. There's the volume of said moon. Last thing that we will talk about then, hemisphere. We talked about spheres. Now, hemispheres is essentially just half of a sphere. In terms of volume, that makes this very easy to deal with. It's just half of the volume formula, because it really is talking about the capacity of that sphere, right? It's just cut in half. But for surface area, this poses a different challenge, because when I cut a sphere essentially into two pieces, we're creating an extra surface. So think about an orange, right? The surface area of surface area of a sphere is 4 pi r squared, right? This is a sphere. So a full orange, essentially that formula will find you the area of the rind, right? The outside. But if you cut that orange in half, you can now see half of the rind plus the actual fruit on the inside if you were to cut it. So if I just divide this formula by 2, really is just getting me half of the rind, half of the skin. But accounting for the actual flesh of the orange, the actual fruit part you would eat, you've introduced another circle. So the surface area for the hemisphere is actually 3 pi r squared, which is not as intuitive as you would think, right? So the 2 pi r squared pieces, so let's break this into two parts. 2 pi r squared, this would be half of the rind, the actual skin, and then the other pi r squared is the flesh part you can now see. Okay, so just be careful if you try to do the surface area of a hemisphere. It is actually 3 pi r squared, not 2 pi r squared. 2 pi r squared only gets you half of the skin, forgetting about that other circle, because now you can see part of the fruit. Okay, so there's the part we'll do for surface area. So when we're asked to find the surface area to the nearest tenth of a hemisphere with a radius of 8, I need to use 3 pi r squared. So my surface area, 3 pi r squared, equals. So if I plug this in, the only thing that really that really affects this surface area, again, just the radius. So as long as I've got 8, now I can grab my calculator and plug that stuff in. So 64 is 8 squared, multiply it by 3, multiply it by pi, and there we go. 603 to the nearest tenth, 0.2, and our units centimeters squared. So there's the surface area of that hemisphere with that dimension. Now if we talk about this in terms of the volume of a sphere is 4 over 3 pi r cubed, like we just mentioned together. So if it's a hemisphere, I'm going to divide that number by 2, or that formula by 2. So really, instead of it being 4 over 3, it'll be 2 over 3. 4 divided by 2 gives us that 2. So this is actually the formula that I need to use. 2 over 3 pi r cubed. This will do this for a hemisphere. Or if you don't like that, one extra thing to remember, you can actually use the full volume formula for a sphere, get the actual number, then divide it by 2 in the end. Either way, we get the same result. So if we're doing, so a hemisphere still has a radius of 8, we're asked for just the volume of it. So again, all I need is the radius measurement. That is the only measurement that affects anything to do with volume or surface area. So the volume is 2/3 pi 8 cubed. And our number then turns out to be 8 to the power of 3. Multiply it with pi. Multiply that by 2. And then divide that by 3. So this time I just put it in parts. And there it is, I think to the nearest tenth as well. 1072.3. 1072.3 centimeters cubed this time, since we're talking about volume. Okay, so that essentially talks about all of the possible volume cases that we will see. We've got pyramids, we talked about prisms, cylinders, all of those things. So what we're going to take care of in our next video together is we will talk about those composite shapes. What happens when you start to put 3D objects together, finding their surface area and their volume. So I hope that helps as well. Take a look back here soon for that next video. And again, you can find the blank copy of notes, solution copy of those notes in that description box. So again, stay safe, and we'll see you in the next one. Take care.